Have you ever wondered what existed before the Big Bang? Does the concept of before even make sense in a universe where time and space as we know them began with the primordial explosion? In this video, we will explore one of the most intriguing questions in cosmology. What was there before everything began? We'll challenge the idea of linear time and explore how the laws of physics might offer clues about the birth of the cosmos. If you're fascinated by scientific theories that challenge our understanding of the universe and want to explore the relationship between time, space, and the origin of the cosmos in an accessible way, this video is for you. Prepare to discover a new perspective that may change the way you think about reality itself. Let's embark on this journey together and try to unravel the mystery at the heart of modern cosmology. Trying to conceive of what existed before the Big Bang is a complex task because the very concept of before loses its meaning. The Big Bang was not just an explosion of matter, but an expansion of time and space, which means that time, as we know it, originated from that moment. Before that, there was no before, at least not in the traditional sense. For many scientists, this means that discussing what happened before the Big Bang is more of a philosophical exercise than a physical one. But if there's no before, what do we do with the idea of time? How does our perception of time change when we look at the beginning of the universe? This is the starting point for some of the most intriguing theories about the origin of the cosmos and the very concept of time. The Big Bang is the central theory describing the origin of the universe, but it also has profound implications for the very concept of time. Before the Big Bang, classical physics can't describe what was happening because the laws of physics as we understand them break down at a singularity, a point that is infinitely dense and hot. It is from this singularity that time, space, and matter began to expand. The Big Bang was not an explosion in space, but an expansion of space-time itself. This initial event marks the beginning of time as we know it. But to understand what this means, we need to look at Einstein's theory of relativity, which suggests that time is intertwined with space. This relationship between time and space formed the fabric of the universe, space-time, which stretches and curves with the presence of mass and energy. In the beginning, the universe was extremely compact, and any attempt to look before the Big Bang takes us into a realm where the laws of physics still don't offer clear answers. Although the Big Bang is the most widely accepted explanation, several alternative theories attempt to make sense of the idea of a before. One of these is the cyclical universe model, which suggests that the universe did not begin from a singular point, but instead goes through cycles of expansion and contraction. In this scenario, the Big Bang is not the origin of the universe, but merely the latest explosion in a series of cycles. This theory implies that the universe has existed cyclically, without a definitive beginning or end. Time would be eternal, flowing in infinite cycles of cosmic births and deaths. The idea of a cyclical universe is not new. Philosophers like Plato and Hindu thinkers explored the notion of cosmic cycles. However, with the advances of modern physics, this theory has gained new interpretations. Scientists like Roger Penrose have proposed that after each great contraction, the universe could expand again, creating a new cycle with a new Big Bang at the start of each cosmic era. If the universe truly follows an endless cycle, this raises a number of philosophical questions about time. What happens to the idea of a before or an end? In an eternal cycle, these concepts would lose their meaning. But does this really solve the issue? One of the most fascinating theories about what could have existed before the Big Bang is the multiverse. According to this hypothesis, our universe is not unique but part of a vast collection of multiple universes, each with its own laws of physics. If the multiverse is real, the idea of a before the Big Bang becomes even less relevant. This is because each universe could have begun independently, with its own unique timeline, separate from the others. The multiverse can be visualized in several ways, such as a collection of cosmic bubbles, with each bubble representing an expanding universe. The theory of the multiverse also ties into the idea that the Big Bang may not have been an isolated event, but rather a transition between different states of the universe, or even between different universes. In a multiverse, the concept of time might be radically different, as each universe could have its own beginning, development, and end. This theory not only challenges the traditional concept of time and space, but also places the idea of a before the Big Bang in a completely new perspective. If we live in a multiverse, the notion of a single point of origin becomes irrelevant. Quantum physics and the implications of this theory raise questions about the nature of reality and whether we are merely observing one universe out of many. On a quantum level, the concept of time becomes even more elusive and difficult to grasp. Quantum physics challenges our conventional notions of time and space. At subatomic scales, time is not experienced in the linear way we perceive in our everyday lives. This is partly due to Heisenberg's uncertainty principle, which states that we cannot precisely know certain pairs of properties of particles, like their position and momentum. This uncertainty suggests that time may not be as absolute as we imagine. One of the most intriguing proposals about quantum time is the theory of emergent time. According to this theory, time is not a fundamental entity, but something that emerges from deeper physical processes. If time is emergent, it calls into question the very idea that it had a beginning. Instead of there being a before the Big Bang, time might be a construct that emerged with the expansion of the universe, a consequence of the universe's initial state. This quantum perspective also suggests that, when studying the universe's origin, we may need to abandon our linear view of time and accept that time might be just one of many ways to measure the flow of the universe. On a fundamental level, time might simply be an illusion. The traditional Big Bang model suggests that the universe began from a singularity, an infinitely dense point where the laws of physics, as we know them, collapse. This raises the question, if the Big Bang is the beginning of everything, what does before really mean? In classical physics, the singularity of the Big Bang doesn't allow for a concrete explanation of an earlier time, as the concepts of time and space themselves no longer make sense. With Einstein's theory of relativity, we understand that space and time are intertwined, forming what we call spacetime. But as we approach the singularity, spacetime collapses in such a way that we can no longer apply the laws of physics we know. This suggests that at the moment of the Big Bang, time as we understand it began to exist. In this context, before wouldn't just be a gap in our knowledge, but something that simply doesn't make sense within modern physics equations. This view of time as something that begins with the universe implies that, in some way, the Big Bang marks a definitive cut in the continuity of time. Without this marker, it wouldn't be possible to talk about a before in any meaningful physical sense. What does this mean for our understanding of time itself and the existence of the universe? This is the philosophical and scientific dilemma that remains open. The idea of a before the Big Bang leads us to a fundamental philosophical question. What does time really mean? Philosophers and scientists debate whether time is a real entity that exists independently of us, or if it is a construct of our perception. If time depends on our observation or the structure of the universe, then discussing a before the Big Bang becomes a difficult concept to grasp, since according to modern theories, time itself would have started with the universe. This reflection on time also intersects with the concept of causality, the idea that everything that happens has a cause. The Big Bang is often viewed as the primordial event from which everything originated, but what caused the Big Bang itself? Is the cause of the Big Bang an unanswered question, or is there something deeper that we have yet to access? Some philosophies suggest that time and space are merely temporary manifestations of something even more fundamental, something that transcends our current understanding. Thus, when we explore the before, we are not just challenging the limits of physics, but also our very notions of existence, causality, and how we experience reality. This question becomes not just scientific, but deeply philosophical. Would time even exist if the universe had never existed? Exploring the before the Big Bang is not just a quest to understand the past. It is also a way to understand where we are heading. If time, space, and the universe have a starting point, does that imply they also have an end? Or will the universe continue to expand indefinitely, eventually dissolving into a state of emptiness? Questions about the beginning are inevitably tied to questions about the fate of the cosmos. Theories like the multiverse and cyclic universes, for example, suggest that the end of one universe might just be the beginning of another. This idea puts us in a unique position. What if our universe is merely a link in an infinite chain of existence? Though speculative, this thought helps us reimagine our role in the cosmos. We are not just passive observers, but part of a much larger and more complex system than we ever imagined. At the same time, investigating the before teaches us about the limits of science and philosophy. It shows us that some answers may always be beyond our reach, but that the search itself is valuable. It expands our understanding, fuels our curiosity, and makes us ask, if the universe had such an extraordinary beginning, what other mysteries are still waiting to be discovered?